In this section, we will be using the F distribution for hypothesis testing with two variances. The steps are very similar to the previous hypothesis tests that we've looked at so far. Two things to point out: S1 squared must represent the larger sample variance. So we are going to be given two variances, and the sample with the larger variance must be declared as sample 1. And the test statistic is S1 squared over S2 squared. We'll be using rejection regions on question 1, but when we get to the calculator, we can use the p-value method. A restaurant manager is designing a new system that is intended to decrease the variance of the time customers wait before their meals are served. Under the old system, a random sample of 7 customers had a variance of 400. Under the new system, a random sample of 16 customers had a variance of 256. At alpha equal to 0.05, is there enough evidence to support the claim that the variance of the waiting times under the old system is greater than the variance of the waiting times under the new system? Assume both populations are normally distributed, use the rejection region method, and show all work. So the old system sample variance is 400, and the new system sample variance is 256. So because 400 is greater than 256, the old system will be sample 1, and the new system will be sample 2. So the claim is that sigma 1 squared is greater than sigma 2 squared. And this is the alternative hypothesis. So the null hypothesis states that sigma 1 squared is less than or equal to sigma 2 squared. Alpha is 0.05. So the sample 1 variance is 400. Sample 1 size is 7. The degrees of freedom for the numerator are the sample size minus 1. So 7 minus 1, which is 6. S2 squared is 256. N2 is 16. The degrees of freedom for the denominator are 16 minus 1, or 15. The critical value is 2.79, and we refer to the table for that value. Now F is equal to S1 squared over S2 squared. So 400 divided by 256, which is 1.56. So the picture looks like this, and F would go right here. So F is not in the rejection region. So we fail to reject the null hypothesis. And the conclusion would be, at the 0.05 level of significance, there is not enough evidence to support the claim that the variance of wait times under the old system is greater.